In the silent expanse of the cosmos, where light travels for billions of years and galaxies dance in gravitational ballets, there lie secrets that have eluded us since time began. Between those galaxies, in the quiet dark where gravity reigns supreme, something extraordinary is happening, something we weren't supposed to see. There are regions of the universe where light cannot reach us, where stars are born in clouds of gas, where galaxies swirl in near-complete obscurity, and where entire epochs of cosmic evolution are concealed behind dust veils millions of light-years thick. These are the domains where even the most powerful optical telescopes fall short. The James Webb Space Telescope, humanity's most ambitious eye into the universe, has begun to peel back the layers of cosmic history, revealing phenomena we've only dreamed of. Its ability to detect faint infrared signals lets it peer into dust-filled regions, into the first stars and galaxies that lit up the universe, and into the otherwise undetectable engines powering galaxies, supermassive black holes hidden from view. It was built not just to see farther, but to see differently, to capture the faint warmth of starlight from when the cosmos was in its infancy. Every observation peels back a layer of the universe's ancient past. Every pixel tells a story that light alone cannot. Quasars, those brilliant beacons powered by supermassive black holes, have long been our lighthouses in the distant universe. Their intense luminosity pierces through cosmic dust, illuminating the very moment galaxies began to form. These powerhouses can outshine entire galaxies, and their discovery reshaped 20th century astronomy. They are the cosmic fireworks of black hole growth, feeding frenzies where matter spirals inward, heating to extreme temperatures, releasing torrents of radiation. But not every black hole makes such a spectacle. But what if those dazzling quasars are just the loudest voices? What about those that grow in silence, buried under layers of dust and time, quietly rewriting the early history of the cosmos? Then came the little red dots. Discovered in ultra-deep field surveys, these mysterious compact objects sparked questions. Were they dim galaxies forming their first stars, or something else entirely? Their faint red glow betrayed their distance, and possibly their age. But their energy signatures didn't match any known type of object. These were no ordinary galaxies. They were whispering something we hadn't yet learned to hear. They were neither bright enough to be quasars, nor inactive enough to be truly dormant. They existed in a strange liminal state, bright but hidden, powerful but hushed. That's where the power of collaboration came in. Using the Subaru telescope in Hawaii to detect visible light, and the James Webb Space Telescope to observe in the infrared, researchers constructed a fuller picture of these enigmatic objects. The deeper they looked, the more they saw. A population of galaxies hiding something remarkable in their cores, actively feeding black holes that didn't look like anything we'd seen before. These objects were previously misclassified or ignored, but when the data sets were layered together, a new portrait emerged, one that revealed subtle fingerprints of accretion, radiation, and gravitational disturbance. The galaxies weren't inert. They were alive with hidden activity. This breakthrough came from a diverse team of scientists. The study was led by Yoshiki Matsuoka, Associate Professor at the Research Center for Space and Cosmic Evolution at Ehime University. Alongside him were Simon Lilly and Jorrit Matthey from ETH Zurich, Daisuke Kashino of Nagoya University, and Christina Eilers of MIT. Their paper was published on May 7, 2025, on the preprint database rArXiv, and it is already sending shockwaves through the astrophysical community. This isn't merely a discovery, it's a redefinition of how we identify and classify black holes. It's the opening chapter of a much larger story still unfolding. What makes these black holes so elusive is their camouflage. Swaddled in dense cocoons of cosmic dust, they radiate very little visible light. To optical telescopes, they might appear as inert blobs or starless galaxies. But under infrared light, their heat glows like embers through a veil. JWST's infrared instruments were able to cut through that obscuring material, revealing what lies at their hearts. This dust doesn't just hide black holes, it also fuels them. Gas and particles are drawn inward by gravity, heating as they spiral into the abyss. The process generates vast energy, most of it smothered by the very dust that makes it possible. Only JWST, sensitive to that long-lost warmth, could detect the faint afterglow of this celestial consumption. These hidden black holes aren't detected by their light, but by their influence. The team observed highly ionized neon gas, a glowing, ghostly fog energized by radiation too intense to come from mere starlight. The presence of this gas was the fingerprint of something powerful, a black hole feeding on matter, emitting energetic photons, and shaping its host galaxy from the core outward. The gas acts like a forensic clue, a smoking gun for black holes that don't want to be seen. Neon V lines, in particular, offer an unmistakable signature of ionization states only possible in the presence of extreme energy. Even in our local universe, the pattern repeats. In the southern Pinwheel Galaxy, also known as M83, signs pointed to a central black hole, but none had ever been conclusively identified. With JWST, astronomers finally uncovered infrared signatures pointing to an active galactic nucleus, a hidden black hole surrounded by gas, dust, and mystery. It's a sobering realization. We may be surrounded by galaxies that are alive in ways we never detected, structures silently evolving under the gravitational command of central black holes, undetected until now. Galaxies once thought to be quiet may in fact host smouldering engines, pushing, pulling, and influencing their environments across cosmic time. The Mega Survey, short for MIRI, EGS Galaxy, and AGN, has turned this hypothesis into a growing catalogue of evidence. Thanks to JWST's precision, scientists are now uncovering entire populations of these dusty, hidden, active galactic nuclei. They had gone unseen by earlier missions, buried in veils of interstellar matter, quietly influencing the cosmos for billions of years. These findings suggest we've been undercounting black holes in the early universe. The most numerous kind may not be the bright quasars, but these quiet, powerful, camouflaged chameleons. The implications are profound. These black holes may represent a vital phase in cosmic evolution, a step between initial seed formation and luminous quasar ignition. They suggest that black hole growth may begin in obscurity, long before the visible light show of quasar activity. Understanding this stage may help us explain how the universe evolved so quickly in its first billion years. It offers a missing piece in the timeline, a way to reconcile black hole mass in young galaxies with the speed of cosmic evolution we observe. Galactic collisions, common in the early universe, often channeled vast amounts of gas into galactic centers, sparking bursts of star formation and feeding central black holes. These mergers may be the origin of the hidden black holes we're now beginning to uncover. Their early lives were violent, their energy hidden, their roles vital. And it's possible that many of today's luminous quasars began in these dark, dusty phases, first growing in silence before erupting into brilliance. We used to believe that seeing was understanding. But these black holes remind us that visibility is not the whole story. The universe is full of hidden forces, shaping, moulding, and directing the fates of galaxies in near silence. These cosmic chameleons change how we think about black hole growth, galactic evolution, and the fabric of the early universe. They are the unseen sculptors of the cosmos, and at last we're starting to know their names. Thanks to the James Webb Space Telescope, the silent giants are finally speaking. Subscribe to our channel and follow the unfolding story of the cosmos. Because in a universe this vast, even the quietest forces leave the deepest marks.